We need to fill in this chart, and in order for us to do that is we need to resolve the component of each of these series and parallel combination. So some of the components already have the value, so all we need to do is to write them down here in the chart. So for R1, we have 3 ohms. For R2, also 3 ohms. For R3 is 1.5. For R4, it's 2 ohms. Another given is the voltage source, which is 8 volts. Now, in a series parallel combination, it is best to start outside or from the outside going inward. Now, this only means that we need to resolve these components first, since R3 and R4 are the one located in the outermost part of the series in parallel combination. So when we combine R3 and R4, we have to give it a new name. So let's call R3 and R4 as our R sub A. And R3 and R4 are in series, so we can just simply add them, R3 plus R4. So R3 is 1.5 ohms plus R4, which is 2 ohms, and then that will give us 3.5 ohms. Now, if we will redraw the circuit, so it will look like this. You have the R1, the R2, right? And then the combined 3 and 4 resistors. So again, let me choose a different ink. This is R1, this is R2, and then this is RA. Right? Don't forget that RA is made up of R3 and R4. So it is a combined resistor into 1. Now, let us resolve R2 and RA. So R2 and RA, they are in parallel. So we can uh, rename it, no, the combined R2 and RA as R sub B. Okay? Again, let me repeat that R sub B is actually a resistor that is parallel with one another. No? In our case, it's R2 and RA. So to resolve for RB, okay, to resolve for RB, let me put it here. So I will use the product over sum. So that's going to be R2 multiplied by RA all over by R2 plus R sub A. So I will just plug in the value for R2 and RA. R2 is 3 ohms multiplied by RA, which is 3.5 ohms, all over by 3 ohms plus 3.5 ohms, and that is 1.62 ohms. Okay? So that is the value for R sub B. What is R sub B again? R sub B is the combined R2 and RA. So if we will re-illustrate R1 with RB, so it will look like this. Okay? And then, of course, we have the voltage source here. Disconnect it. And let me label this as R1. And this is our R sub B. Okay, what is our R sub B again? R sub B is made up of R sub 2 and R sub A. Now, by looking at this circuit, right, we can easily tell that R1 and RB are connected in a series connection. Therefore, the current that is flowing in the circuit or current that is flowing in R1 and RB are just the same. So, let us resolve now for the total RT since these are the only resistors left. So, we have to find an equivalent resistance, or we will represent these two resistors with one resistor. So, if this is the voltage source, the equivalent resistor is something like this. Okay? So, you have your REQ or R total. Alright? So, since R1 and RB are in series, we can say that our RT or REQ is equals to R1 plus R sub B, Our R1 is 3 ohms plus our R sub B is 1.62 ohms. Okay? And the total is 4.62 ohms. Right? So the 4.62 ohms is just like this. If you will redraw it, okay, having a single or a one resistor to represent all the resistors connected. Okay, now we computed the RT, which is 4.62 ohms. We can now determine the total current in the circuit. How do we do that? So we follow Ohm's law pa rin. I sub P is equals to V sub T over by R sub T, which will give us 8 volts over by 4.62 ohms, and that will give us 1.73 amperes. All right, 1.73 amperes. Now let's examine again this circuit. The total current is 1.73, and the circuit R1 and RB are connected in series, right? So this only means that the amount of current that is flowing in R1 and RB is equal to I sub T. So we can say that I sub T is equals to I sub 1, which is also equals to I sub B. And their value is 1.73 amperes. Right? Now, since R1 and RB is in series, we need to compute for the voltages. So voltage for V1, voltage for resistor 1, okay, for this one, that is going to be V sub 1 equals to I sub 1 R sub 1, which is equals to 1.73 amperes multiplied by 3 ohms, and that will give us 5.19 volts. The next one is this. So that's going to be V sub B, I sub B, R sub B, right? So that is 1.73 ampere multiplied by 1.62. Okay? Our RB, R sub B is 1.62 ohms. Ito yun. And then, that will give us 2.8 volts. Right? Now, to check if V1 and VB correspond with the total voltage, we just simply take the sum. No? We'll just add 5.19 and 2.8. So that means total voltage is equals to V1 plus V sub V. Where did we get that? Dito natin kukunin. No, we will add the voltage here with V sub B. Okay, so that's going to be 5.19 plus 2.8, and that will give us 7.9 volts, or ito na sabihin 8 volts. So, since 8 volts to, okay, and the total voltage is also 8 volts, then we are on the right track. Okay, now let us try to plug in the necessary values needed for our chart. Okay, so our IT is 1.73 amperes, and IT is the same as I sub 1, right? I sub 1. So I will plug it here, 1.73 amperes. What else? V1, okay, this is V1, that's 5.19. Now, if we will look B sub B and open it, we know that R sub B is actually made up of R2 and RA, which are connected in parallel. So that means whatever the voltage of R sub B is also equal to V sub 2 and V sub A. So we can say that the voltage V, which is 2.8 volts, is also the same with V sub 2 and V sub A. Okay? So V sub 2 here in R sub 2 and V sub A in R sub A. Okay, now let us try to solve for our I2 and our RA since we identified their voltages already. Okay, so I2 is equals to V2 over by R sub 2, which is equals to 2.8 volts all over by 3 ohms, and that will give us 0.93 amperes. Okay, so let me write it down in the chart, 0.93 amperes. And then for IA, okay, for our IA, so that is going to be IA is equals to V sub A over by R sub A. So VA is 2.8 then, all over by 3.5 ohms, and that will give us 0.8 ampere. Okay, 0.8 ampere. Now, we have to keep in mind that IA, okay, that IA is made up of R3 and R4, which are connected in series. Therefore, we can say that our IA, okay, our current A, is also similar to current 3 and current 4, right? Which is also 0.8 ampere. Why are they similar? Because they are connected in series, like this. Remember the 3 and 4, okay? Resistor 3 and 4 are connected in series and they are called R sub A. Okay? Now, let me plug in first the value for I3 and I4. I3 is 0.8 amperes and I4 is 0.8 amperes. Let me repeat that. These two are the same or having the same amount of current because they are connected in series. Right? So, the only difference is that R3 and R4, they will have a different voltage inside them. So, we can solve that. So, we can solve it using this V3, I3, and R3. So, I3 is 0.8 multiplied by R3, which is 1.5 ohms. And this is ampere, the 0.08, or rather the 0.8. And that will give us 1.2 volts. And then for V4, so that will give us 0.8 multiplied by 2 ohms. And that will give us 1.6 volts. So let me just plug in. V4 is 1.6 volts and V3 is 1.2, and for V2 2.8 volts. To check for VA, right? To check for VA, all we have to do is add V3 and V4, and that will give us the same answer, which is 2.8, right? So that is how you solve for the different component of a series parallel combination.